GitHub Action is an integrated tool for continuous integration and continuous deployment, or CI/CD. It's established itself as a key player in software development by providing a robust platform for automating development and deployment workflows. But it doesn't stop there. We're going to explore how GitHub Actions can be helpful in the data domain too. It can streamline processes for developers and data professionals by automating tasks like data retrieval from external sources and transforming data. In this video, we will dive into the 4 levels of GitHub Actions that can help automate your data workflows. We'll begin by understanding the reasons behind using GitHub Actions for automating data workflows. First, you can automate setting up your data project environments, such as installing dependencies and required packages like Pandas or PyTorch. Next, GitHub Action enables creating an iterable data science lifecycle. This means streamlining data integration and transformation steps, automating the training of machine learning models whenever new data comes in and deploying those models to production automatically. Additionally, there are many community resources available, like marketplace templates and forums where you can get support. Besides, GitHub Action is almost free to use. It offers unlimited usage on GitHub-hosted runners for public repositories and gives you 2,000 free minutes of compute time per month for private repositories. Now, let's talk about what is GitHub Action and its core components that allow you to automate workflows directly within your repositories. These workflows are defined using YAML files and can be triggered by various events. If you've ever set up automation on your devices, like turning on dark mode at a specific time, you're familiar with the idea of a trigger point. In GitHub Actions, we call this an event. It can be time-based, like running on the first day of the month, or triggered by behaviors, like pushing changes from a local repository to a remote one. The second component is the workflow, which is made up of a series of jobs. GitHub lets you customize each step in a job to fit your needs. You typically define this in a YAML file stored in the workflow subdirectory of your repository. The third component, runners, are hosted environments that run your workflows. Instead of running a script on your laptop, you can use GitHub-hosted runners to do the job for you, or even specify a self-hosted machine. Each time a workflow runs, it creates a run. You can check the logs of each run in the Actions tab, where GitHub provides an interface to visualize and monitor those logs. Now, let's explore the implementation of GitHub Actions through 4 levels of difficulty. We'll start with the minimal viable product and gradually introduce more components and customization. Level 1 is a simple workflow with Python script execution. Start by setting up a GitHub repository for your workflow and Python script. Inside your repository, create a .github/workflows directory. This is crucial for the action to execute successfully. Here's what a basic YAML file might look like. It breaks down into 3 sections. First, define the workflow name as simple workflow. Then, on workflow_dispatch specifies that this workflow runs when triggered manually. Finally, the job section outlines the steps involved. Runs on Ubuntu latest, specify the runner or a virtual machine to run the workflow. Ubuntu latest is a standard GitHub-hosted runner containing an environment of tools, packages, and settings available for GitHub Actions to use. Then, apply a pre-built GitHub Action checkout at v4 to pull the repository content into the runner's environment. This ensures that the workflow has access to all the necessary files and scripts stored in the repository. Lastly, run Python code hello world.py. Execute the Python script located in the code subdirectory by running shell commands directly in your YAML workflow file. Level 2 is a push workflow with environment setup. The first workflow showed us a minimal viable version of the GitHub action. However, it didn't really tap into all the features that GitHub Actions can offer. Here, we're going to add a bit more customization. This time, we'll automatically set up the environment with Python version 3.11, install the required packages, and execute the script whenever changes are pushed to the main branch. Here's how that YAML file looks for this setup. Let's break this down a bit. Push command is really important because it means the action will run whenever there's a push from the local repository to the remote one. This is common in software development for integration and deployment processes. It's also used in MLOps workflows, making sure that any code changes are consistently tested and validated before they get merged into another branch. Plus, it helps with continuous deployment by automatically rolling out updates to production or staging environments as soon as changes are pushed. We also added a condition to only trigger this action when it's pushed to the main branch. Moving on to the uses, actions/setup Python at v5 step, we've included the setup Python action. This is the recommended way to use Python with GitHub Actions because it ensures everything works consistently across different runners and Python versions. Then, we streamline the installation of required packages with the command to install everything listed in requirements file. This makes building our data pipeline and data science solution faster. If you are interested in the basics of setting up a development environment for your data science projects, my previous blog post 7 tips to future-proof machine learning projects, with link in the description, provides a bit more explanation. Now, let's move on to the third level, scheduled workflow with argument parsing, where we add more dynamics and complexity to make this workflow more suitable for real-world applications. We introduce scheduled jobs, which allows us to periodically fetch more recent data. This reduces the need to manually run the script every time we need a data refresh. We also use dynamic argument parsing to run the script based on different date range parameters according to the schedule. Here's the YAML file. It will run on a specific schedule, which we set using a cron expression 0.12.1* to trigger at noon on the first day of every month. We then check out the repo, set up Python, and install dependencies as before. In the run data pipeline step, we run a series of shell commands where we define 2 variables to get the first and last days of the previous month. These variables are passed to our Python script to fetch data dynamically for the previous month. To allow the Python script to accept custom variables via command line arguments, we use argparse library to build the script. This deserves a separate topic, but here is a quick preview of how the Python script would look like using the argparse library. Finally, in our fourth level, we're focusing on improving the security and performance of our GitHub workflow by building a secure workflow with secrets and environment variables management. To improve workflow efficiency and reduce errors, we're going to add a check before committing changes. This way, commits and pushes only happen when there are actual changes since the last commit. We can do this using the command git diff staged quiet echo changes equals true to GitHub_env. Let's break that down. First, git diff staged checks the difference between the staging area and the last commit. The quiet option suppresses the output. What that means is, it returns 0 when there are no changes between the staged environment and the working directory. If there are changes, it returns an exit code of 1. This command connects to echo changes equals true through the OR operator. This tells the shell to run the rest of the line if the first command fails. So, if changes do exist, changes equals true gets passed to the environment variable GitHub_env. Then, we can access this variable in the next step to trigger a git commit and push, based on the condition that environment change is true. Next, let's talk about environment secrets. These enhance security and help avoid exposing sensitive information, like API tokens or personal access tokens, in our codebase. Plus, environment secrets allow us to separate the development environments. This means you can have different secrets for different stages of your development and deployment pipeline. For example, in the testing environment, like in the dev branch, you can only access the test token. Meanwhile, in the production environment, like in the main branch, you'll have access to the token linked to the production instance. So, you can set up the environment secrets in GitHub in your repository settings. Navigate to Secrets and Variables section, then go to Actions. Click on New Repository Secret and add your secret name and value. Once you've set up the GitHub environment secrets, you'll need to add the secret to the workflow environment. For example, we added secrets.news_API_token to the step labeled run data pipeline. And update the Python script fetch_data.py to access the secret using os.environ.get. Thanks for reaching the end. This guide explores the implementation of GitHub Actions for building dynamic data pipelines, progressing through 4 different levels of workflow implementations. If you found this video helpful, don't forget to like and subscribe for more content like this.